So we'll have a look at the expected value and see what that is all about. And with some of you might have noticed before that this e of x, the expected value of a random variable x, is sometimes equated to the mean. So this Greek letter mu is the symbol for the mean. And so what is the difference between expected value and mean? And one example that might explain this is, let's say you have a coin toss where you flip a coin 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say 10 times. And now we let the color red, that's going to be heads. So if you toss a coin 10 times, well, let's say that this happens, and this might happen. Okay, the first 4 is a head, and the next one is a tails, and the next 4 are also heads. Now, you would say this is not what I expected. So you didn't expect that 8 out of the 10 coin tosses would result in a head. Now, the way to find the mean in an experimental situation where you have real data is, well, you add up all the values and then you divide that by the number of values. So we could simply add together all the heads that we have here and divide that by the number of coin tosses, which is 10. So the mean in this case is 0.8. So this is the experimental mean, if you like. If you examine a data set where you have lots of different values, then you would add together those values and divide by the number of values in the data set. Another way of saying that is that mean, understood this way, is relevant for real data. So we can call this the experimental mean. And usually when we talk about mean, that's what we mean. Now, the expected value is what you would expect to happen. So if you have a coin toss where the probability every time you throw the coin is 0.5, you would expect sort of every other coin toss to be either heads or tails. And this rarely happens, but that is sort of the theoretical expectation or the theoretical probability. So when we talk about expected value, it's a sort of theoretical mean. We could say this as that the expected value is the theoretical mean, what you would expect to see if probability was the same thing as certainty. But it isn't. And probability is different from what is going to happen. So probability is not the same as certainty. But expected value is what you would expect to happen if everything plays out according to the probability. How is expected value calculated then? Well, in this case, we had a number of trials. We tried 10 times, 10 coin tosses, and the probability for each coin toss is 0.5. And how many heads do we expect? So x is the number of heads that we expect, and we expect that there will be 5. Now, if the probability changes, if you have a biased coin, let's say the probability is 1. So how many heads would you expect then? I mean, a probability of 1 means that it's certain that it's going to happen. So if you toss a coin 10 times, you would expect to see 10 heads. More generally, we can write this as the expected value of an event is the number of trials multiplied with the probability in every trial. This is what we see in the examples here, that you have 10 trials with a probability of 0.5. You multiply the number of trials with the probability, and same with the other example.